Pad and parking lot modeling. The goal of this material is to get comfortable with 3D modeling workflow in Select Series 3 Open Roads technology. During this course, we will take horizontal geometry elements, add vertical geometry to them, and then grade them relative to each other or to a terrain model. We'll be creating a building pad surrounded by a yard or apron, as well as a sloped parking lot, sidewalk, and driveway elements. For clarification of terms, a lot is a shape that may be level, sloped, or otherwise graded, versus a pad shape, which is always level or flat. The yard or apron is the area between your pad or lot and the offset boundary shape. For drainage, the yard is generally sloped away from the pad or lot. Linear pavement lines such as sidewalk or driveway are used for connecting pavements, not defined by pushing a template. When creating vertical geometry based on terrain model elements, the profile from surface command is appropriate. The settings determine where the points along the horizontal will read elevations, which of those elevations will be used, and also allows for offset value. This is a great tool for creating a pad profile, which we'll see in the first exercise. Profile from surface allows a variety of profile options draped from existing ground, and the profile geometry settings can be edited in the element information dialog or via the context-sensitive heads-up display prompts. Geometry relationships are held, so if the terrain model has a change, then the profile created will adjust accordingly. Most lines in a 3D engineering model are related to another 3D line, horizontally, vertically, or both. Tools that have an offset functionality get used readily. Very often, the vertical relationship is a constant or variable slope from an element, but another way to profile is determined by extending slope between two elements. The profile by slope from element tool handles the constant slope relationship, and the profile by variable slope from element handles the other varying scenarios. In 3D modeling, there should be a profile element created for every horizontal element. Depending on the tool used, the vertical geometry may not be set active when it is created, so we should take the added step to set it active and check the feature name and feature definition. We must set the profile active, and we must verify the 3D element creation in the 3D model before continuing to apply linear templates or create a terrain. Terrains are not automatically created. One reason we create terrain from 3D elements is because contours depict 3D space well and are a fantastic way to identify errors in your design. Terrains provide full spatial coverage, which can be useful for linear objects, and any element passing within a terrain can show terrain in a profile. These images show the same 3D elements. The vertical relationship is almost impossible to discern from the linear elements alone. Any template in the template corridor can be dropped along a corridor to create a 3D model. A corridor is not required to extrude a template. However, any template can be extruded along a 3D element. The Apply Linear Template tool assigns a template to an element simply by selecting the 3D element, then selecting the template, and then identifying which side the template belongs. Any template, simple or complex, can be used. Let's take a look at this practice exercise where we'll create a pad and yard.